Hello everyone. In this video, I am going to discuss how we can integrate using partial fractions decomposition. So we will first, look at this particular case. Here we have got the variable in the denominator and we know we can apply the formula 1 over x, integral of 1 over x dx is equal to ln of mod x plus c. So I'm going to apply the same formula directly over here. So we will get ln of mod x minus 5 plus c. So that's a straightforward. When we are having a constant on the numerator and we are having a linear function in the denominator, we can directly use this identity 1 over ln 1 over x dx is equal to ln mod x plus c. Look at this case. Here we have got variable on both top and bottom. But a very fantastic thing is there that I want all of you to observe. Look at this denominator, and if you will look at here and if you will try to find its derivative, you will see the derivative is written here. So if you're having a case when you are having the derivative of the function is in the numerator and the function is in the denominator, we can easily use something called substitution. So we will use substitutions for finding this integral. So in order to do that, what we are going to do, first we will write let u is equal to x square minus x plus 5. So I will differentiate both the side with respect to x. This will give us 2x minus 1. So it implies that du is equal to 2x minus 1 times dx. Alright, now is the time to substitute. So what we have got, 2x minus 1 dx will be replaced by du, and this x square minus x plus 5 will get replaced by u, and hence we can directly apply integration of du over u is going to be ln mod of u plus c. So this is going to be equal to ln modulus of x square minus x plus 5 plus c. So here if I write a general formula, when you are having a function and its derivative written on the top in the numerator, you can directly write its integration is going to be ln of modulus of that function plus c. Okay, so now we will see the next case. What you will do in this case, here we have got 7x minus 4 divided by x square minus 2x minus 8 dx. Here clearly if I will differentiate this, if I assume let u is equal to x square minus 2x minus 8, and if I try to differentiate it with respect to x, we will get 2x minus 2, which is not same as 7x minus 4. So in these are the cases where it is actually very good idea to use partial fractions decomposition. So what we are going to do there in partial fraction decomposition, we want to decompose this fraction such that we have got a over a factor plus b over a factor. So our variables are in the denominator only, and when we will integrate, we can directly apply the integral of 1 over x. You will see how we are going to do it. Before we go further, let's see how fraction works. So if I have got, let's say 1 over 3 and I want to add 1 over 5 to it, what we do? We first try to make this denominator same so that we can add the fraction. So we will multiply this denominator by 5, and hence this numerator will also get multiplied by 5. Here we are going to multiply this denominator by 3 and this numerator by 3. Hence we will get 5 over 15 plus 3 over 15, and when we will add it we will get 8 over 15. So we want something to do here with this algebraic fraction that we have got. We want to decompose it in this 1 over 3 plus 1 over 5 form. Okay, so let's see how we can do that. So the first step that we are going to do over here is that look if we could factorize it. Here I have got x square minus 2x minus 8. It's a quadratic expression that I have got, and we can rewrite it as, we need the product as minus 8 and the sum as minus 2. So we can write x minus 4 times x plus 2 dx. If you're having difficulty how I factorize it so quickly, I will be making another video on quadratic factorization and you can watch it later. So this is what we have got. You can check it by yourself. If you will multiply them, you will get x square minus 2x minus 8. All right, so the next step is that we want to write it in the form a over x minus 4 plus b over x plus 2, and ultimately this has to be equal to x 7x minus 4 upon x minus 4 times x plus 2. You see, if I get a constant here instead of a, and if I try to find the integral, it will be very easy. That constant times ln x minus 4, that's going to be my answer. Here, finding the integral in this 7x minus 4 over x square minus 2x minus 8 is going to be a difficult task, and that's why partial fractions are going to be a handy tool. So next what we are going to do, let's multiply both the sides by x minus 4 times x plus 2. So if I am going to multiply both the sides by x minus 4 times x plus 2, a over x minus 4 plus b over x plus 2, which is equal to 7x minus 4 upon x minus 4 times x plus 2. So what will happen? If we will get, it implies that a times x plus 2, because this x minus 4 and this x minus 4 will get cancelled. Next we will get b times x minus 4, and here we will get only 7x minus 4. So that's the equation that we have got. So our equation is now reduced to a times x plus 2 plus b times x minus 4, which is equal to 7x minus 4. So the next thing that we are going to do, we are going to use the elimination method. We want to find the value of a and b so that we can plug it in here in these 2 points, and we will use the integral. So I'm going to use the elimination method, and in the elimination method I will first say let x is equal to minus 2. When I'm saying x is equal to minus 2, what will happen? A times minus 2 plus 2 plus b times minus 2 minus 4 is equal to 7 times minus 2 and minus 4. So this will become 0. A times 0 is going to be 0. Here we will get b times minus 6, so that will give us minus 6b, which is equal to minus 14 and minus 4. It implies that minus 6b is equal to minus 18. It implies that b is equal to minus 18 divided by minus 6, which will give us 3. So we got b is equal to 3. All right. Next is we are going to assume we are going to eliminate this b in this time, and so that we can find the value of a. So b let x is equal to 4. So we will have a times 6 plus 0 is equal to 28 minus 4. So 6a is equal to 24. It implies that a is equal to 4. So we got the value of a and b. From here we got a is equal to 4. So we got 4 over x minus 4 dx. We will just substitute it back in this equation, and next we have got 3 over x plus 2 dx. Now the best part is we can apply the logarithms integral over here. We can directly write 4 times ln mod of x minus 4 plus 3 times ln mod of x plus 2 plus c, and that's my answer. So you can see how this partial fraction decomposition is helping us to get the integrals of all these rational functions. Okay. Now we will do one more example. You can see in the numerator we have got 6x minus 2, and in the denominator we have got x square plus x minus 6, and clearly we can't use substitution method over here. So we are going to use the partial fraction decomposition that we have learned. So step 1 is that we have to factorize the denominator. So if we will factorize the denominator, I will write numerator as it is. So 6x minus 2 dx over here. See, we have got a quadratic function, and in this quadratic expression we have to get the product as -6 and the sum should be 1. So here the two numbers that I can think of is 3 and -2. So I will rewrite it as x plus 3 times x minus 2. Next step, we will try to find it. We will try to find two a and b's such that I can write it as a over x plus 3 dx plus b over x minus 2 dx. So now our job is to find the value of a and b. So in order to do that, what we are going to do, we will write it as a over x plus 3 plus b over x minus 2 is going to be equal to 6x minus 2 over x plus 3 times x minus 2. So we are going to multiply both the sides by this thing, x plus 3 times x minus 2, which will give us, it implies that a times x minus 2 plus b times x plus 3, which is equal to 6x minus 2. Now we will use elimination method. We will try to first eliminate the terms containing a and b. So first I am going to eliminate this a. So I will assume let x is equal to 2. Putting x is equal to 2 will give me 0 over here. So I will get a times 0, which is 0, plus 5b is equal to 12 minus 2. So it implies that 5b is equal to 10. It implies that b is equal to 2. Alright, now I will do one more calculation. Here I will try to get rid of this b. So let x is equal to minus 3. If I will put x is equal to minus 3, what I will get? I will get 8 times minus 5 plus 0 is equal to minus 18 minus 2. So it implies that minus 5a is equal to minus 20, and it implies that a is equal to 4. So we got the value of a and b. So we got a is equal to 4 and we got b is equal to 2. So now we will substitute these values back in the equation. So we have got a is equal to 4. So we will write it as 4 over x plus 3 dx, and here we will have plus 2 over x minus 2 dx, and we will find their integral. I can directly apply the formula integral of 1 over x is equal to ln mod x. So we will have 4 times ln mod x plus 3 plus 2 times ln mod of x minus 2 plus c, and that's my answer. We will do one more question now where we are going to have a little bit bigger numbers. These are the kind of questions which are very common when you will be trying to solve equations involving differential equations where you have to integrate. So here it is already being, the first step is already being done for you. They are already factorized. So what we will do here, we will write it as, we want to write it as a over x dx plus b over 200 minus x dx, 200 minus x dx. I will clear this x for you all. Okay, so let's find the value of a and b, guys. What I have said before, we will first write it as a over x plus b over 200 minus x should be equal to 1 over x times 200 minus x. Okay, so I'm multiplying both the sides by x times 200 minus x, which will give us a times 200 minus x plus bx, which is equal to 1. So we will try to use elimination method. First step is let x is equal to 0. I am putting x is equal to 0 so that I can get rid of this b. So it implies that a times 200 plus 0 is equal to 1. So it implies that a is equal to 1 over 200, right? Similarly, to get rid of this a, I have to put let x is equal to 200 and see what we are going to get. So we will have a times 200 minus 200 plus 200b is equal to 1. It implies that this will be 0. So we will get 200b is equal to 1. It implies that b is equal to 1 over 200. So that's good. We have got the same quantities, like a and b both are equal. Next step is to find their integral. So we will write it as 1 over 200 times x dx plus 1 over 200 times 200 minus x dx. So let's integrate. So the first step would be, I will write 1 over 200 as it is. I'm taking it out of the integral, and then I will have ln of mod x plus, here we will have 1 over 200 times ln of mod 200 minus x. And one more thing, you can see over here our variable has a negative sign, so we will divide it by minus 1 plus c. So my final answer is going to be 1 over 200 times ln of mod x minus 1 over 200 times ln of mod 200 minus x plus c, and that's my answer. So I hope this video has helped you to how you can use partial fraction decompositions for integrating. It's a fantastic tool, and use it. You can rewatch this video. If you have got any kind of difficulty, please write it in the comment section and I will try to help you out. Thank you for watching.